Welcome to Wild Basin Wilderness Preserve. This preserve protects 227 acres of beautiful Texas hill country habitats right here in Austin. It's part of the much larger Balcones Canyon Lands Preserve, which covers about 50 square miles. Many rare and vulnerable species of animals and birds live here. That's why we protect the land. This is a great place to enjoy being outside and learn about the natural world. Ready to go exploring?
Oh, hi! We were just about to enjoy some creek water here at Wild Basin. Wait, what? This is not safe drinking water? That's right. We're enjoying these basic bottles of filtered drinking water and not creek water. Thanks, Dion. The water was just so clear, I assumed it was safe to drink.
Yeah, it's pretty important to understand and measure the quality of water. Luckily for us, our friend and St. Edward's alum Adire Oabete is here to explain it to us.
Hi, my name is Adidaroma Wobte. I'm a recent graduate of St. Edward's University. I'm a lab technician and also a water quality specialist, and I'm here to talk to you today about watersheds. A watershed is an area within a region where surface water, groundwater, and rainwater collect. So what is surface water? Bodies of water that you can readily identify. Streams, lakes, rivers, all the things that you can visually see. Then you have groundwater. These are more underground aquifers, things that wells tap into. And then rainwater is rainwater. And these all collect into the watershed, and that is where we get most of our drinking water. So the body of water here at Wild Basin is called Bee Creek. Bee Creek ends up flowing into Lake Austin. So Lake Austin is one of the 3 bodies of water that are drinking water sources within the city of Austin, along with the Colorado River and Lady Bird Lake. Okay, so now that we've learned a little bit more about watersheds, let's talk about pollution and how we pollute our local watersheds. So there's 2 main ways that we can pollute. There's point source pollution and there's general pollution. General pollution comes from our everyday activities like gardening. You've got pesticides and fertilizers that when it rains, the extra nutrients can collect in your local watershed. You also have sediments from construction, or you have sediments from your garden. You can also have, like, when you walk your dog and you don't pick up the poop and things like that. All of those collect in your local watershed. Point source pollution are the big additions to pollution. They're things that you can literally point at and you know that that's polluting water. So an example of point source pollution would be construction sites. That's a lot of sediment that is added into, when it rains, it gets added into our local watershed. You also have oil companies, pharmaceuticals, all of these things their effluent can get entered into the watershed and it can pollute our water. So there's 2 different types of testing, or there's 2 different scientific monitors. So we have local water quality scientists like me that we test water that is meant for fishes, lakes, like your general water quality indicators, your above ground water. I'm testing for nitrates which come from fertilizers and pesticides. I'm testing for the pH level. I'm also testing for temperature. That's a big one for water quality. And I'm testing for dissolved oxygen, so the amount of oxygen that is within a water system. Then you have the other kind of scientists that are removing contaminants from water. These are what is happening in the wastewater treatment plants. They're clarifying our water enough so that we're able to drink again, and that's the water that comes out of your tap. That's the one that you're drinking. So back to surface water. Surface water is what primarily affects our fishes, our lakes, all the great hiking spots that you love to go to that have like these great rivers and streams. We have to make sure that they're clarified enough so that fishes and other amphibians can live within the water. So right now I'm going to test for pH. pH is an indicator of how acidic or basic a water sample is. So you don't want a sample that is too acidic because nothing can live in something that is too acidic. But you also don't want something that's too basic because it amplifies the effects of heavy metals and toxins. So you want it right in the middle at around 7.5. It can go down below 6.5, but it also can go up to 9. But you really want it in the middle of 7.5. That's the most ideal environment for fishes, or like fish and aquatic life. Okay, so I'm gonna grab my pH indicator. I'm gonna grab my test tube and a disposable pipette and our comparator. So basically what we're gonna do is we're gonna grab a water sample, we're gonna put 10 drops of our pH indicator inside of it, and then we're gonna put it inside our comparator and hold it to the light to see what level our pH is in. So we have 7, 7.5. This goes all the way to 10.5. I don't really expect this stream to be lower in acidity. I don't expect it to be acidic, so I'm not going to use the other half of the comparator. So let me go grab the water sample. You guys stay right there. Submerge it completely, rinse it out, submerge it completely, rinse it out, submerge it completely, and then, oh, yeah. You want to make sure it doesn't touch the bottom. Then you get this. And so what I would do here is I would take sample, because I want it to reach the 5 milliliter mark. Okay. So right here, you want to grab the water sample from somewhere that doesn't have too much debris. So you're going to grab it, kind of submerge water sample. Make sure that you don't touch the bottom of the river or the water surface that you're testing in. You want to rinse your test tube twice. And then on the third one is when you would collect your sample. That just makes sure that you're rinsing out anything that might be in there. And so right now we want it to reach the 5, I don't know if you guys, you want to reach the 5 milliliter mark. So I'm going to take out enough sample so that the meniscus reaches the 5 milliliter mark. And you could just squirt it back to where it came from because we haven't put chemicals in it yet. Okay, just a little bit more. So right here, we can see that it's right between 7.7 and 7.5. I would call that 7.5 on any paperwork that I would document it on, but that's great because it's right in the middle like we want it. So again, pH is just one of the many indicators that we have for water quality. It tells us how acidic or basic a sample is. We also have nitrates. Nitrates tell us the level of nitrates will affect how much algal bloom we have in a system. Temperature, we don't want a temperature that's too hot for fish. Like, it's not really good, especially for any amphibian species. And then dissolved oxygen is the amount of oxygen that you have within a sample. It's basically what the fishes use to breathe, so we want to make sure that there's enough oxygen within the water sample. So we need to be really careful with all of the things that we do on a day-to-day basis, and we also need to hold big companies accountable to make sure that we're not polluting our local watersheds. Not only is it our drinking water, but it's also a whole ecosystem for these amphibians, so we need to be careful.